guys, welcome to Math1141 videos. So this time I'll talk about algebra, chapter 5, question 50. Okay, let A and B be two matrices with differ only in the first column, i.e. let A equals to A1, A2 to the AN, B equals to B1, A2, A3 to the AN. So basically it means like matrix 1 A and matrix B is the same, but only difference is they replace first column by B1, right? So where A1 and B1 are the first column of A and B, and where I equals 2, 3 to M are remain column of both A and B. Okay? And let C be the matrix. C equals to A1 plus B1, A2, A3 to the AM. Which means replace A1 by A1 plus B1, and the rest will be remain the same. Obtained by replacing the first column of A or B by sum of the first column of A and B. Show that determine C equals to determine A plus determine B. So they ask us to show determine of A plus determine B equals to determine of C. Explain why result of this question also hold for adding two matrices which differ only in one column, not necessarily in the first, or which differ only in one row. Okay, it's basically asks us to explain why. It's like this equation also hold if we didn't change A1. For example, we change A5 to the B5, and we change A5 to the A5 plus B5. Like new matrix C will equal to new matrix A plus new matrix B. Okay. Now let's look at this question. So A equals to A1, A2 to AN. Right? Now we just need to find a determinant because they ask us to find out the determinant, right? So we can write out the determinant. So just say this is column 1, so we say column 1 first row, column 1 second row, and column 1 third row. Right? So just like this, we write it like not the usual way, but you guys should understand it's like A1 and 4 first row, second row, third row, fifth row, kind of like this. Right? So we write out the determinant, right? Now we need to calculate the determinant. See, we've got two ways to calculate the determinant, right? Usually we just rip off the first row, first column, first row, second column, first row, third column. And same here, first row, first column, first row, second column, first row, third column, right? But quickly you will find out that if we do it in this way, for example, first row, first column, okay, it's fine because first row, first column, we got exactly same determinant here. Right, so it seems like no problem here, but we're going to take first row and second column, first row and third column. Something not good happened, right? Because least determinant will be different from least determinant, right? So how are we going to solve this? So basically we know from our lecture notes, determinant of this matrix will also equal to determinant of its transpose, right? So this determinant is what? It will be equal to its transpose, which means it will going to be equal to 1, A11, A12, A1, right? Transpose, A21, A22. Right? Because from our original, determinant will be equal to its transpose. Right? So same thing happen here. Determinant of B will going to be equal to determinant of A, of the transpose of B, which will going to be equal to B11, B12, B1. A21, A22, A2. Right? So determinant of B will equal to determinant of transpose. Right? Now we can start to calculate the determinant. It will be going to be A11 multiplied by determinant of the rest, A12 multiplied by determinant of rest, and so on, right? So A11 multiplied by determinant of no first row, first column, right? Minus A12, because plus minus alternate, right? 1, 2. So no first row, second column, and keep going, right? And plus minus. For example, plus 1, 3, A13, minus A14, A14, and you're going to be keep going, right? So plus -1 power of n plus 1, A1n. Right. You can see pattern here: 1, 2, 1, 1, 1, 2, 1, 3, 1, 4 to 1n, and plus minus, right? So 2 we're going to have minus, 3 we're going to have plus, so we're going to have n plus 1 power, right? I think you guys can see a pattern here, right? If you got even number here, you are going to have minus. Odd number here, you're going to have plus. And then if we want to write it in sum up form, which will be k equals 1 to n, A1k, A1k, and minus 1. Oh, sorry. Okay. We can write it as sum up form, right? So same strategy here for determinant B. We can write it as B11 multiplied by first row and first column, and then we will find out like it will be exactly the same as A11, right? Say first row and first column, it will be exactly the same. So we'll write it as A11, right? So minus B12. So first row, second column, and then we'll find out it will be exactly as same as determinant A12. First row, second column. So write 2. And same thing happened here. So it's just keep going. It's going to be B13, A13 minus B14, A14. Right, and keep going to -1, k plus 1, B hope you guys can see the pattern here. B11, B12, B13, B14, keep going to B1n, and A11, A12, A13 to A1n, plus minus, plus minus, plus minus. So it seems like we're nearly here. Why? We're going to add up determine A and determine B, right? So we can add up determine A and determine B, which is sum from k to 1 to n, h1 k plus 1, a1k, a1k, right? Plus sum of k equals to 1. Right? And we combine them together, we're going to be sum k equals to 1 to n, 1k plus b1k. Right? And I hope you guys can see this is the determinant of matrix C. Why? Because determinant of matrix A, if we got A1 in the first row, first column, right? So we're going to have A1 like this. So A1, A1, 2, A1, 3 in the front. So sum of A1K in the front. So if we got B1 in the first column, we're going to have B1 in the first row, right? So we got B11, B12 to B1n. So we got B1K here, right? So if we got A1 plus B1 in the first column, right? So we're going to have A1 plus B1 in the first row, right? So we're going to have A1 plus B1, 1, A1 plus B1, 2, so A1 plus B1n, right? So we're going to have A1 plus B1, K, right? So equals to C, right? I hope you guys can see y is equal to C. If you don't quite understand, you can just try to expand out. Going to be just expand out and put it back. We're going to A11 plus B11, A12 plus B12, and keep going to A1n plus B1n. We got B21, A22, A2n. Keep going, so we got A1, A2 to AN, right? And we make a transpose. It's going to be in the first column, and which is C. If you guys not sure how we directly go from this part to determine C, you can look at this extension, right? So I think it's easy enough to understand. If you guys can see why we can immediately jump from A1K plus B1K, A1K to determine C, you guys just ignore this part. If you guys don't understand, you can expand it out and then transfer it back to the form of determine C, and you will see why this part is determinant of C. Okay, now we proved determine C equals to determine A plus determine B, right? Now we can explain why the result of this question also hold for adding two matrices which differ only in one column, not necessarily first, or different only in one row. So which means they don't choose first column, probably they choose second column as B, or third column as B, or second row as B, or third row as B, and so on. So does this going to change the results? I will say no. Why? Because remember, from the lecture note, we can move the column anywhere we like, or move the row anywhere we like. Right? So if they choose a different column, we can move the column to the first column and do the same procedure here. Right? If we choose a row, we can move the row to the first row and do the same procedure here. Right? And if we're going to move the row or column, only thing it's going to change is what? The sign. Right? It's going to be plus or minus. Right? So we may get plus or minus determine A, or plus or minus determine B, plus or minus determine C. But the important thing is the sign for A and the sign for B will be same, and it will be same to the sign C. So if we got negative determine A here, we're going to have negative determine B here, and we're going to have negative determine C here. If we're going to have positive determine A here, we're going to have positive determine B here, and we're going to have positive determine C here. Why? Because we're moving the same row. If we're moving second row here, second column here, you're going to be moving in the second column. Move the second column, right? It will move the same column or same row for A, B, C. So sign will be the same. So this equation always holds. So I think that's pretty much it. So I hope my explanation helps. Thanks for watching.